Have you ever looked up at the night sky and wondered what's really out there? Beyond the stars, we can see the universe is filled with mind-bending mysteries that even the smartest scientists on Earth can't solve. Today, we're diving into the 10 biggest cosmic puzzles that have stumped humanity for decades and still do. So, buckle up, because we're about to question everything you thought you knew about reality. First up, the ultimate clash of titans: general relativity versus quantum mechanics. General relativity, Einstein's masterpiece, perfectly describes the big stuff: planets, stars, and galaxies. It's all about gravity and the curvature of spacetime. On the other hand, quantum mechanics governs the bizarre world of the super small atoms and subatomic particles. Both theories are incredibly successful in their own domains. But here's the problem: when you try to use them together, like to describe what happens inside a black hole or at the very beginning of the universe, the math just completely falls apart. It's like having two different instruction manuals for reality that contradict each other. Finding a single theory of everything that unifies them is the holy grail of modern physics. Solving it wouldn't just be a neat trick. It would rewrite our understanding of the cosmos from the ground up. Next, let's talk about the universe's invisible majority. Everything we can see: stars, planets, you, me. This entire studio makes up less than 5% of the universe. So what's the rest? Well, about 27% of it is something called dark matter. We can't see it, touch it, or detect it directly. So how do we know it's there? Gravity. So we see its gravitational pull holding entire galaxies together, preventing them from flying apart as they spin. Imagine a cosmic ghost that's 5 times more common than regular matter, shaping the structure of the universe, but we have absolutely no idea what it's made of. Scientists are running massive experiments deep underground, trying to catch a stray dark matter particle, but so far, nothing. It's one of the most profound and humbling mysteries out there. But wait, it gets even weirder. If normal matter is 5% and dark matter is 27%, what about the other 68%? That, my friends, is dark energy. In the late 1990s, astronomers were trying to measure how much the expansion of the universe was slowing down due to gravity. To their utter shock, they found the exact opposite. The expansion isn't slowing down, it's speeding up. Something is pushing the universe apart, acting like a sort of anti-gravity. We've named this mysterious force dark energy, but naming it is the easy part. We have no clue what it is, where it comes from, or why it exists. It's as if the fabric of space itself has an inherent energy that's driving everything away from everything else, leading to a future where galaxies will be so far apart they'll disappear from our view. Now for a question of existence itself: the matter-antimatter asymmetry. According to our best theories of the Big Bang, energy should have created equal amounts of matter and its evil twin, antimatter. When matter and antimatter meet, they annihilate each other in a burst of energy. So, logically, the early universe should have been a cosmic war zone that ended in a stalemate, leaving behind nothing but pure energy. But that's not what happened. For some reason, a tiny fraction of matter, about 1 particle in a billion, was left over. That tiny imbalance is the reason anything exists. That's why we have stars, planets, and people. But what caused this crucial asymmetry? Why did matter win? We're here because it did, but we have no solid explanation for why. Let's rewind to the very first moments of the universe. Our model suggests that in the tiniest fraction of a second after the Big Bang, the universe underwent a period of insane, faster-than-light expansion called cosmic inflation, supposedly inflated from smaller than an atom to bigger than a galaxy almost instantly. This idea beautifully explains a lot of things we observe today, like why the universe is so uniform and flat. The only problem is what caused it. What was the engine that drove this incredible expansion, and what made it stop? The theory of inflation is a cornerstone of modern cosmology, but the physical mechanism behind it remains a complete mystery. Let's journey to the most extreme objects in the cosmos: black holes. Here's the paradox. One of the fundamental rules of quantum mechanics is that information can never be destroyed. It can be scrambled, but it's always there in some form. But what happens when something, say a book, falls into a black hole? According to Stephen Hawking, black holes slowly evaporate over time, releasing radiation. But this Hawking radiation seems to contain no information about what fell in. So, where did the information in the book go? Did it get destroyed, violating the laws of quantum mechanics, or does it escape somehow? This is the black hole information paradox, a deep conflict between general relativity and quantum mechanics that has physicists pulling their hair out. Speaking of particles, let's talk about the standard model of particle physics. This is our current best theory describing all the known fundamental particles and forces, except for one huge omission: gravity. The standard model works incredibly well, but it's incomplete. It doesn't include gravity. It has no particle for dark matter. and you can't explain why tiny particles called neutrinos have mass. It's like having a list of all the ingredients for a cake, but not knowing what a whisk is or why you need sugar. We know the standard model isn't the final answer, but figuring out what lies beyond it has proven incredibly difficult. Here's a simpler, but perhaps even more profound question. Why does time only move forward? This is known as the arrow of time. The fundamental laws of physics, for the most part, work just as well forwards as they do backwards. A video of a planet orbiting a star would look perfectly normal if you played it in reverse. But in our everyday lives, time is a one-way street. Eggs break, but they don't unbreak. We get older, not younger. This directionality is linked to entropy, the idea that systems tend to move from order to disorder. The universe started in a very lone, troopy, highly ordered state, and it's been getting more disordered ever since. But why did it start in that special, ordered state in the first place? Nobody knows. With trillions of galaxies, each with billions of stars, many with their own planets, the universe should be teeming with life, right? This is the heart of the Fermi paradox. The numbers suggest that alien civilization should be common. So, where is everybody? Have we not looked hard enough? Is interstellar travel just too difficult? Or are we, against all odds, truly alone in the cosmos? Are advanced civilizations destined to destroy themselves before they can reach the stars? This silence from the cosmos is both fascinating and a little bit terrifying. Finally, the grandest and most speculative idea of all, the multiverse. Is our universe the only one? Some theories, like cosmic inflation and string theory, naturally suggest the existence of other universes, possibly with completely different laws of physics. Imagine a multiverse of countless bubble universes, each with its own unique properties. In one, gravity might be stronger. In another, there might be no life at all. Is this just a wild science fiction concept or a genuine possibility? The problem is, by definition, these other universes are likely beyond our ability to ever observe or test. It's a tantalizing idea that pushes the boundaries of science itself, from the nature of reality to our place within it. These 10 mysteries show us just how much we still have to learn. They're not failures of science, they are the frontiers. Every question we can't answer is an opportunity for discovery, a clue that could lead to the next great leap in our understanding of everything. Solving them could unlock new technologies and a reality we can't even begin to imagine. What do you think is the most fascinating mystery? Let me know in the comments below. Thanks for watching, and if you enjoyed this journey into the unknown, don't forget to like and subscribe for more cosmic adventures.